That's great. Really nice. So, like as we talked about constant acceleration, now these are the formulas which would be followed when the acceleration is constant, and the acceleration would be constant when velocity is uniform, right? In that case there would be no variation in the velocity, and because of that acceleration would be constant, like remaining constant, and would be like zero in that part. So not considering the zero part, constant means acceleration is gonna be the same for some point of time, right? So if a particle
Yes.
is moving in a straight line with constant acceleration, these are the equations that you're gonna use. So do not get confused in them. I'm gonna tell you three important equations on which maximum questions are formed, right? So please tell me if you can see what I'm writing on the board. Like I'm taking some equations. So this one and this one and this one. Three equations are most important, right? So
Yes,
these
ma'am.
are the equations on which maximum numericals are also like formed, and they are gonna be there in your paper. Like no doubt, no question will come on this. There would be questions, and hopefully their derivation could also be there. So we are gonna go for that as well.
So, ma'am, these three will be mostly used.
Yes, yes, yes. Mostly in most numericals, these would be used. Please do one thing. Please write down the heading as formulas for constant acceleration. Copy this out, and also like copy the equations that I have taken. Apart from that, do not like it's not important. Do not note the rest two equations, but note the three equations. Right?
Yes, ma'am.
Yes.
Okay, I'm noted, ma'am.
Okay, that's great. Really nice. So, Nyasha, now I guess from here you will be also getting the part what we are gonna do. So, these are the terms. Especially Vanya, this is for you. You do not remember what component means, like means what in the equations. So, especially this is for you. So, in these equations, S is the displacement. Either it can be height or the distance, right? U is the
Yes, ma'am.
initial velocity of the body, V is the final velocity, A is your acceleration, and T is your time period. Also, their SI units are listed. Meters, meter per second inverse, like for initial and sorry, meter per second for velocities, meter per second square for acceleration, and seconds for time, right?
Yes, ma'am.
Nyasha, in case if there is any problem, please unmute yourself and ask, right? Um, like I think, I don't know, your networks are fine, Nyasha? Just give me a quick thumbs up if it's fine.
It's clear, ma'am.
Okay, 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 okay. So let's move ahead. Okay. So we are gonna now see how we derive the equations, right, Panya? And
Yes, ma'am.
Nyasha, we are gonna see how we derive the equations. So probably we are gonna do that one by one. So first equation that we would be deriving is your v is equals to u plus at, right? So here, this is your velocity time graph. Okay. Uh,
Yes, ma'am.
Firstly, let me know what is the gradient, the slope for velocity time graph. Nyasha, can you please tell me about that?
I don't have any idea, ma'am.
Okay, you do not like remember for the graphs, but it's important. It's important. Please do have a revision on that as well. Like I know the session is a little bit chaos because like it's just your second session, and first session was literally about discussion on syllabus only. So probably when we will be going for the new topic, that it's gonna then you will also get on the track, right? But in this, I think this is in kinematics. This is the very fresh topic that we have started about equations. Okay. So I guess like till here in kinematics we have completed through the graphs of motion, the motion graphs. Okay. And now we have started, today is the fresh topic that we have started, right? Probably
Yes, ma'am.
this is gonna be helpful for you as well, Nyasha. So please look at that. So let me then,
You want
uh,
you want the gradient of the line.
yeah, sorry, your voice is cracky. Your voice is cracky,
The
Nyasha.
gradient of a
Can you please
line.
repeat?
You mean the gradient of this line? It's v minus u over t.
Yes, yes, yes. No, 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 no. I'm asking which quantity is given by the gradient. Which quantity? Like for distance time graph, the gradient is speed.
Accel-
So that is what I'm asking.
Acceleration.
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 Exactly. Really nice. Really nice. Yes, Vanya, please tell me what you want to say.
Oh no, I wanted to give the gradient. That's all.
Okay, okay. Is that fine?
Yes, ma'am.
Okay, that's really nice. So now, please give me an idea if you remember anything about that, Vanya or Nyasha. Any one of you can answer me. What should be my first step to go in the derivation?
The acceleration, which is the gradient of the line, is equal to v minus u over t.
Yes, exactly. That's really nice. And I guess we have studied about. Okay, okay, no, not till now. Like in acceleration part, right, Vanya? When we were doing the acceleration part, we saw the formula for acceleration. So, yes, the gradient for this graph is your acceleration, and acceleration is the variation in the velocities. So, final velocity v minus initial velocity u over t time period. Is that right, Nyasha and Vanya?
Yes, ma'am.
That's great. Now we are gonna just multiply t with the
It's
we'll take this
clear.
t. So this will be equal to v minus u. Is that right? Please tell me if any confusion is still here. So like when you'll rearrange, you'll get v is equals to, this u is in negative. When it will go on the opposite side of the is equals to sign, this will become positive. So u plus at. This is gonna be how we are gonna derive the formula. Please tell me if that's fine, Nyasha and Vanya.
Yes, ma'am.
Okay, that's great.
It's clear.
Yes, yes. Okay. So let me see if we have a proper. Okay, just a second. So let's look it out the solution for that as well. So by definition, acceleration is the rate of change of velocity that we discussed. So with that, it's going to be the change in velocity over time period, which is this step. Then you'll rearrange that. And finally, you'll get v is equals to u plus at. Is that fine? Please remember that these derivations are important. Like there are chances, or you can also say 80% chances are there that these derivations would be present in your exam paper, right? So please do one thing, write down the heading as derivations for the equation of motion. Like I'm going to write the heading here. Derivation for equations, just a second, equations of motion. So this is your heading, and then please write down the first equation, uh, and please go on. Do not write any excess, which is like the lines and lines, the paragraphs and paragraphs present. Just draw this graph and do this part. Nothing has to go with. Okay, please go with this.
Yes, ma'am.
Okay. So Nyasha, my question is to you, like, specifically for physics, what do you find difficult? What do you struggle with? Any part which you feel like you can improve, you can work upon? The theory or the numerical, the graphs? What is that?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grade 6 to IGCSE, AS, and A-level. Start learning with us today.
Come again, ma'am.
Yeah, sorry.
Your voice is not clear.
My voice is not clear. Maybe, Vanya, is the voice clear to you as well, or is that cracky for you as well?
No, it's clear to me.
Okay. So Nyasha, I'll suggest if it's still cracky, if my voice is still cracky, please quickly refresh and rejoin quickly. And if not, then it's fine. Is it fine, Nyasha? Now it's fine?
Yeah, now it's audible.
But I little bit feel like for me it's cracky, your voice.
My voice.
Like partially, I can hear the words partially, but it's not clear.
You just don't check on it. You. Yeah, we can continue, ma'am.
Okay, yes. Now your voice is clear. So, please tell me, what is the part that you feel like you are struggling with, you need to work upon? The theory or like the numerical?
Projectile motion.
Okay. Sorry,
Projectile
projectile?
motion.
Projectile motion.
Projectile motion. The projectile motion.
Okay. So, like, this is a
Mm.
projectile motion is a specific topic for kinematics only, but I'm like asking for the whole physics in general. What is the part that makes you confused?
Work energy and power.
Work energy and power. Yes, Vanya.
I just wanted to note that everything is confusing to me because I'm new to physics. So
No problem. See, if like I'll probably like from my side, I want to like tell you some of the students are afraid from mathematics, okay? And because of that fear of mathematics, like get scared from the physics as well. But no, it's not the case. Physics is actually a really nice, and if you give it a little bit more time, a little bit more practice, a little bit on theory, it's gonna give you scores, like it's gonna have wonders for you, right? So
yes.
it just requires a bit amount of time from you, okay? And it's not like you sit for 6 hours, 7 hours and go and no. You just need to give proper with full concentration, just give like half of 1 hour, right? Half or like half minimum hour or 1 hour. You just give it to daily to physics, okay? Um Go for theory, read theories, try numericals, practice them, and it's gonna be really easy for you. And apart from that, like when you'll go study regularly, struggles are gonna come, like you'll get to know several of doubts, and that's gonna be like, it's gonna be resolved. Like, I'm here because of that. So uh like, see, one more like hair in Keddy. One more like, your Super Saturday programs have been started, and what's gonna happen? Like, I'm telling this to you early so that you can prepare for that. Like, every like, from the groups, I'm gonna like take some of the kids individually. Like, for an example, I'll take you one year, okay? Like, next Saturday, if I take you for the Super Saturday, what's gonna happen? You will get a doubt session, okay? So for that, you can like keep your doubts aside, and whatever doubts in any chapter, any theory, any numerical, any conceptual part, you are free to ask me out, okay?
Yes, that would be great.
Yes. So probably it can happen like randomly for everyone on rotational basis, and for you as well, Nyasha, you can also go for that. Just keep picking out your doubts and writing that on a paper, right?
Yes, ma'am. Ma'am, I just wanted to add,
Okay, ma'am.
since we didn't start from SI units and, like right from the beginning, will we start like right from the beginning at any time, or are we just going to continue like this?
Sorry. From the beginning, basically, what? Okay. Are you saying that we are gonna continue what's going on in the class, or we are gonna do something else? Are you saying that?
Yes, yes, ma'am, because the chapters from AS level start from SI units and physical quantities, and then it carries on. But on my case, I started from work, energy, and power. So that's why I was a bit confused because
No. See, that's not a problem. That's not a problem. Every chapter would be taken. But
okay.
see, if you are specifically talking about the Saturday individual session, so that is like a great opportunity for you. Reason?
Yes, ma'am.
Reason is that the session totally depends on you. Like, if you want to go with the doubts, we'll be catering the doubts. If you want, like, if you have pick out some specific topics, not chapters, the topics, the subtopics. For an example, in kinematics, you say projectile motion is a problem for you. So that's a specific topic from the chapter. So if you pick out the topics that create problem for you, I'm going to take that, right? So it's an advantage for you, the Saturday part. So I'm telling this to you earlier so that you can prepare for that, right?
Okay, ma'am, will we have the session starting from tomorrow or next week Saturday?
Tomorrow is a session, like as I said, it's gonna be on rotational basis. Kids are gonna be like selected randomly, right? So tomorrow
Okay.
certain kids are there, but probably if I have a choice, I can give you the next like probably I have a choice, so I'm gonna give you the next Saturday session to you, right?
Okay, thanks, ma'am.
Yes. So that's the same for you, Nyasha. So please keep preparing. Please like bring your doubts, keep your doubts separately, or any theory part if it's there. Please do write out a plain of a paper so that when our Super Saturday comes, like you do not have to think about what to do and what to ask, right?
Yes, ma'am.
So like as I said, please quickly note this down. Draw the graph as well. Once you are done, please let me know. We are going to go to the next equation.
Done, ma'am.
Done? That's
Yeah,
great.
Yes.
we're done, ma'am.
Hey, Sasha, are you saying anything? Okay, are you saying that you are done?
Yes, ma'am.
Okay. And what about
I'm
you,
done.
Manya?
Yes, ma'am. Done.
Okay. So let's move forward. So next is like another equation. So probably, please do not go for this part. Go for this one. Okay. Let's understand this as well. Okay. So this is your second equation. Just a second. Yes. So this is your second equation, which is S is equals to UT plus half AT square. So can you see the figure? So probably what you're gonna do, you're gonna find the distance traveled for this, right? Now that's your choice. If you, according to your understanding, you can take a separate graph as well, right? So I think this diagram is a little bit confusing. I'll show you a diagram which you can use for the derivation of this equation. Yes. So see. Just a second. So I'm going to give you the diagram. You can use this diagram. So instead of the diagram which is shown to you in front, like derivation is fine, but the diagram I don't think is that much good. So please understand the diagram that I'm drawing. So this is your velocity time graph again. So this is velocity. This is your t time period. This starts from 0 and the same graph that was in your previous one. So at this point, let's say it's u, initial velocity, and here let's say it's gonna be like at any point it's gonna be v. Okay, so I'm gonna draw the slope now. So slope is gonna be like this. Please consider this as the slope, and t. Can you see the graph? Now, I think this is probably more easy than the diagram which is drawn. So, please see this. From this diagram, what you're gonna do? Any idea how we are gonna derive the equations?
No, ma'am.
Okay, no problem. So when you talk about the distance traveled, that is s. Okay, so you're gonna find here the distance. So what you're gonna see that you probably see it looks like a half trapezium, right? So you can do one thing. You can consider the triangle as well as the rectangle. Can you see this one first and the second? Right,
Yes,
Vanya
ma'am.
and Nyasha. So you can consider these two figures, find the area for them and add those area, right? And when you add the area, you just need to arrange the things. Can you see what is now the area of the rectangle? Area of the rectangle is L into B plus area of the triangle is half into base, half multiplied by base and height. Is that right? Vanya,
Yes, ma'am.
Nyasha?
Yes, ma'am.
Okay. So when when you'll go for, let's go for the rectangle. So what do you see? Can you see the wideness is t, that is, and the height is u. Can you see this? And this is t.
Yes, ma'am.
So in that case, you're gonna write u multiplied by t plus half base. When you talk about the base of the triangle, the first one. So base is t. Right? The base is t and the height, what should be the height? Please tell me. Think on that and please tell me what should be the height. Now height is the full velocity. So I think you you can write it as v minus u. Nasha, you also please give me a confirmation if things are.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Clear till here or not?
They are clear, ma'am.
Okay, that's great.
They are
Now
clear.
from here, like till here we have
Very, very
understood how
clear.
we are. Okay, okay. So till here we are good to go. What step we have followed? After that, we are gonna use this part, the acceleration. We know that acceleration is v minus u over t. So from here you can find the value of at, right? So now probably at the place of v minus u, that is here, you can write at. So probably you're gonna get the equation as ut plus half. This is your at. So at multiplied by one more t, which is at square. So finally you get the equation as s is equals to ut plus half at square. Please see that, Vanya and Nyasha, and tell me if there is any confusion.
Ma'am, can I note it down first and then
Yes, please, please.
leave it?
Okay, so Nyasha, you also go for that. Note this quickly. And in case if there is any doubt, please let me know. Vanya, just give me 1 minute. I'll be back in a minute, okay?
Yes, ma'am.